constructing Etoys, or how to do animation in a fancy way. You see here a little animation. I'm not going to talk about the math concepts because that's self-evident to me, at least. That's one of the nicer Pythagoras theorem proofs. But what I want to talk about is that animation, and if any one of you try to do animations in Etoys, doing that kind of thing is hard. Because you see that little translucency fading in, then the smooth motion of these tiles, I would call them, and then this all goes one after each other, and then all together go back. And making the scripts for that, I couldn't even really imagine how to do it. So I set out to do it in a different way, a reusable way. So just to fit this talk into a half an hour, I prepared a little bit of things. So that's just a rectangle I made. And I gave it a few methods, scripts. So we have a variable that's called fraction and another variable called steps, which actually is an integer. And when I click start, it just starts the ticking script. So that's a script that's called tick. I can start it, it starts ticking, and when it reaches 1, when the fraction becomes 1, it starts it again. So I can also show you the start script. It sets the fraction to 0, and it starts the script called tick. So that's a little bit of meta programming. You're not directly calling the tick script, but you start the tick script. So when I click start, this guy over here starts to tick. And I can also change it to take maybe 50 steps, which will make it slower. So you can see over there, the fraction advances slower, and then in the end it stops again. Is that enough for getting into it? Yes, okay. So adding to that, I'm going to extend that example. So in addition to the fraction and the steps variables, I added a from value and a to value and the current value. So that in the updated method, the current value is calculated from the from and the to. So that's a linear interpolation. So it's adding the to minus the from is basically the delta. It's the distance that this should move. And it's multiplied by the fraction between 0 and 1. So adding that to the from moves that guy over here from the from value to the to value. And just clicking start, you can see that it's moving. Right, and I can change the from, maybe from to 200. And I can change the to, let's say 250, so it's a much smaller distance. Okay. All right. And adding even more things, we don't, for doing an animation in 2D, we need two variables. We need x and y. So I replaced the simple from and to with the from x and from y. So the only thing that changed here is the updated script. So I'm calculating both the x and the y coordinate. And again, when I start this, it's moving from here over here. Or I can say, okay, let's move it over here. So I can see the x is about 500 and the y is about 600. So my 2 is going to become 500 and 600 And when I start the animation, it's going over here. Maybe the from should be, I don't know. So it's doing different animations there. And the next step here, what did I do here? Oh, I added two little methods where I can assign the start point and end point, not by entering the numbers, but just by reading out the current position of the object. So that's going to be my start, and over here is going to be my end. And when I click start, it's moving from here to there. Or I say that's the start, and that's the end. It's moving this way. So far, so good. Any questions? Good. So what we are now, I don't think I need those guys anymore. Now it's going to become interesting. So what I want to do is actually make maybe this little ellipse move from here over here. So I could sit down and write again all these scripts. I don't want to do that. You probably don't want to do that too. So instead of having this guy here move itself, we're going to have it move the ellipse. So I add a little variable, call it target, and that's going to be a player, which is the name of the objects in Etoys. The default, I forgot to do that first. All right. So the default thing is the little black dot. That's the default value. It's an off-screen object, so because it hasn't been assigned yet. But I can say, okay, the target is my ellipse. So what I just did, I clicked here, and I get a little crosshair cursor, and I can say, okay, that's my target. Or that's my target. Or if I really want to, that's my target. Okay. So let's say the target is the ellipse, and then I need to change the updated method, and it should not move D, which is this little rectangle over here, but it should move D's target. So when I now click the start script, oops, there. It's moving the ellipse now. And similar, when assigning the start and the end, I don't want to read the position that the animation tile has, but the target. So it's going to read these target X and these target Y. So I want the ellipse to move from here. I'm assigning the start point to over here. I'm assigning the end point. I click start. It's moving there. So now how to make this even more usable. This is going to be a tile. If I make it this shape, it already looks like a little tile. And clicking in the viewer is not really nice. So I want a button to start this animation. There's a button to fire this script. The Etoys convention is to call that button just a little exclamation mark. I can make it a little bit bigger. I can change its color, yellow, the border color to give it a wider border. Is that visible? Yeah. Works? Okay. So that looks like a button. And I'm placing it here. I'm going to embed it in D. I don't need a slot, so whenever you embed an object in a different one, Etoys helpfully offers to add a slot, because you might refer to it in a script, but we don't. So no, don't add a slot. And now I can just click here to set my, to start my animation. What else would we need? We would want to assign the endpoint, right? So same thing. Going to add a little button here, change it to set, and embed it. So where's my ellipse? Over here. For assigning the start point, usually you want the objects moving in a smooth way. So the start point should be wherever the object is currently. So that's why I'm going to change the start script and just say, okay, before you do anything, assign the start position to wherever you are. And so now I can say, okay, I want the ellipse to move over here. Do it. Or move the ellipse over here. Do it. No. Now about the deconstructing part. I want to be able to change the target of my little animation tile that I'm constructing over here. So the way I do it is, say we have that star over here and I want to play the animation for the star, I would still have to go into the viewer. But I can take this little guy here out of the viewer. I just make a copy.
You can also get a simple watcher from the menu, right?
Yes, but that would be no fun. Because the point is, I can use my Etoys tools to work on the Etoys environment itself. Right? So I can get a halo on the tiles in the viewer, and I can grab stuff out of it to make my new tile over here.
Oh, okay.
And in here I can make it a little bit larger maybe. Okay. So now I can say, okay, that's going to be my target. I'm going to set the position to here and go. And maybe more fun is if I can do, I just held shift down here to make a sibling object. So I copied it. And let's say for this guy, we set the position over here. And now watch. I'm going over here and I'm going over there. Back and forth.
Can you make one the star and one the ellipse?
Sure. So that guy's moving over here. That guy's not moving because it's already there. Right. And now maybe if we allow the star to be the main actor here, then we would want to repeat those tiles indefinitely. So I just grab a holder. Where's the holder? I'm going to add that guy here, that guy. Make it a little bit larger. And so when one animation finished, I would have to inform the holder to please advance to the next tile and start it. So that's not really hard. I'm going to the end thing here. And my holder is going to get a script where it advances the pointer, the cursor. So we want to increase the cursor by 1 when the element ended. Yeah, so if one of the elements did end its animation, it should advance, and then it should start the next element. And to really start the next element, it should use the player that's currently at the cursor position. Right? And in the end method, we need to call the holder's element ended. Now let's try. So there's no good way to stop this loop here, but you can already see I could make it go in a square. I could add a new tile that doesn't actually move the star to wait for a second. I can change the animation to. You see how this movement doesn't look as smooth as the one I showed you before here. So that's because I added a little animation trick there, which is called ease in, ease out. It starts slowly, and it accelerates, then it decelerates before settling down, and then it goes back. So that's a trick animators use to give objects a mass. Right, so that's how real objects move. They start slowly and then they stop slowly. So that's what I added here. It's a simple formula. You can look it up on the web. So basically, what I use is a sine curve. So I just want to have some function that starts slowly, accelerates faster, and then levels out. That's one thing. I'm going to show you one little trick here. So to actually make this universal, because you want to reuse these tiles, right, for many objects. So you wouldn't always call the holder's element ended, but you want the holder of that specific tile. So instead of just using holder here, you would use, that's under miscellaneous, these holder. So that there's no direct reference from the tile to a different object, but it would always use its own, the holder it's in. And also, when the holder ended, maybe let's call the holder sequence. So when the element ended, then, and it's at the end of the animation, then you would like to call the holder's holder element ended, so you can even stack these animations inside of each other. So I'm running out of time, and so will not show that. But the little thing I'm going to do is in here, so to not do this indefinitely, I'm going to test if this sequence is cursor is smaller than the count, and if so, I'm going to increase the cursor by 1. And so it stops here, but I can add a little tile that I might call repeat. And it would get a start method. And in that start method, it would call the holders start method. So the sequence needs a start method too. And what the sequence's start method would do is set the cursor to 1 and call the first element's start. So I can just do this and say the player's at cursor start. So this is now starting the sequence once. Yeah? So it's going there, but because now the sequence's cursor is equal to the sequence's count, it does not advance anymore. But my repeat tile has a start method. Where is it? That would call the sequence's start. So I'm adding this, and instead of calling my own start, it would be my holder start method. So need to drop this in here, and I need a button to fire this, and just to make it look nice, I'm going to call it this, and embed here in the repeat tile. No. And now I can start here, and it's repeating because the holder is calling the repeat tile start method, and the repeat tile start method is telling the holder to start over. And when I drag out that tile, the animation stops. I put it back in, it's going to work again. Just to make it look nicer, I'm going to embed a little, oops. I'm going to embed a little text here. Embed. Oh. So that's my repeat tile. And you get the idea. You can make this look real nice. You can lock down the text, so when I click it, I don't edit it anymore. I can change the appearance of the whole tile here. Maybe this. Oh, that looks nice. Okay. And then, of course, that would be yellow too, and this border style here, yellow. Okay. A little bit larger, and drop in here. So that's basically it. Instead of a sequence that I just showed right now, you can do a holder that animates all its children at the same time. So that I'm going to show you in the finished project. So what I did here is I put all the tiles in a flap, and so there's a do together tile and a sequence tile. That's the sequence. You can also not just influence the position of your object, but any value. So I could do an alpha animation, or I could animate the color, or the angle, of course. Yeah, you want to turn stuff. And I'm showing you the script that's doing this animation here. So where are we? Where's the cursor? There's the cursor. So it's sliding here. It's now just waiting for a second. Then it's it was sliding all these guys together to their original position. Then it slided the yellow square to this place and also adjusted the alpha of the covering red square. Let's do it again here. So. And that's how you could do Etoys animations with weight tiles and whatever you want, purely in Etoys. So it's not built in, but Etoys gives you the tools to build your own tools. And you could use this project as a starting point for your own animations. And that's why I'm saying that Etoys is more powerful than any other kids programming tool I know about. Oops, okay. And just to show you that the turn by tile also works. It's this. So it's sliding the position and turning at the same time. And the one thing I wanted to show you that I did not do in the other thing is in the updated. So that's the formula for doing the ease in and out. So the slow acceleration and deceleration. I actually put in a little flag here, so that's a switch between doing a linear animation and that ease in, ease out. So that's just multiplying the fraction by 2 pi and dividing by 2 pi. So that's the simplest ease in and out I could come up with, or I found on the web. So, thank you, and hope you have a little time for questions.
So you were saying because of the interpreted nature of Squeak, you can't publish these separate tools as libraries? They have to just
Did I say that? No. No, the unit of exchange in Etoys is a project, so that's why I would bundle this as a project and give to someone else. But we could build this into Etoys if we wanted to. Is that what you were asking, or?
Well, like, you know, if we who are not experts on Squeak nor Etoys want to develop animations and not have to reinvent the wheel, which we probably couldn't do nearly as well as you did, I mean, how can we just use that functionality in our projects without, you know,
you would, I would, you could take this project here, remove the actual Pythagoras animation and save that as a template for your students to use.
So this is available to us now?
I'm going to upload it.
Okay.
It'd just be nice to have like a package. You know, like
This
a
is a
tool.
package, yeah.
Right.
That's.
He's got, this project has both the controller and the target. You could grab the project, remove the target, that leaves you with the project with the controller. Now put your own target in there, and I think you're...
And I also, I could do that and you wouldn't know. So you would just get the tools.
I don't even have enough trust in myself to correctly undo what you did and package it correctly myself.
Yeah.
You know, it's just, I guess because of the interpreted nature of the language, you can't really, you know, come up with prepackaged libraries to implement certain functionality.
I don't think this has anything to do with being interpreted or not. It's just that we choose not to. We
I didn't set these questions up, but I like them. So, I mean, the power of this is kids can create their own tiles.
Yeah.
To do whatever they want, or you know, if you wanted to simplify some of the lower level things and have them play with other concepts, you could create your own tile language and your own scripting language. It's absolutely beautiful. And then sharing them, I guess, the one thing is if you put them in a flap, you can copy the flap to another project. And then how would you recommend integrate, so you come up with these wonderful tiles, how would I, sharing all projects, right. So how would I integrate those tiles with the existing Squeak tiles, what would be the recommended method for, is it just calling the script or?
Yes. Did I put that in here? Yes. So I made another tile that just can execute any script.
Oh, I gotta see how you did that, because everyone's in trouble. So you,
so that would, in its start method, it just, oops, it just calls that script. The script name is a variable.
so you just put the variable in there?
And there you'd see all the scripts that are defined in your project.
Yeah, I couldn't figure out how to reference the script name variable, but I'll look at your project and figure it out.
You change the value type to script name.
That part, no, that part I got, but when you stuck the script name watcher into the, oh, never mind, I just realized I did it. That was my stupidity.
Yeah. So what I did here is embed a simple watcher
Mm-hmm.
right in the tile, so I can.
And it'll run that script name associated with the object that is the player you have in that
Yes,
file.
of the target. Yeah. So that's this line here. So the do script is what I call my tile. So do script's target is going to do script.
So when I create my own tiles to integrate with the scripts that are just standard Etoys tiles, it's really my own tiles are the controlling.
Yes, because
I can't call my tile. I mean, I could, but it wouldn't
yes.
be. Yeah, okay.
Okay, I get the signal to stop now.
Can I make one point before you do? Go back to the original screen where where we're just seeing your original animation.
My original animation?
Yeah, where you're moving your hypotenuse square into your two side squares.
All right. This?
Yeah. Okay. Because I do this with my kids. We actually do it with paper and scissors, but we don't move the hypotenuse into the two little ones. We move the two little ones and have to figure out how to cut them up to fit the big one. So I think what I would do, and what I'm going to try to do, is to do that with my kids, and then I'm going to show them yours, where you move the hypotenuse square into the two small squares, and tell them that they have to do it the other way. Take the two little ones and put them into the big one. And so I'm thinking with everything you've got there, it would be fairly simple for them to make that transition. They would just have to figure out how to divide up the small square, the short leg and the long leg squares.
So actually,
Because you moved that little square down. I've never seen it done that way before. Okay.
all right. You have to stop, sorry.
I used to do
What?
this with my kids, and they would do it just like this.
Really, because I have a Chinese puzzle that moves the two small squares and puts it into the large square.
So actually, so I'm not a teacher, but if I was doing that with kids, I much would prefer the physical version to the Etoys version. So I just put this in to spread the idea on the internet, because not everyone knows this proof.
Yeah.
And it's so simple, so convincing that I just had to do it, and I chose to do Etoys to use that as a vehicle for that. But for actually doing it with kids, just cut it out of paper or make it from wood or something like that.
I'm using it to teach Squeak. I'm thinking
Right.
it's something that they already know how to do, and so how do you make Squeak do
If the goal
something?
was to teach Squeak, then this is a
Yeah.
good application. If the
Yeah.
goal was to do the proof, then I would do it with
Paper.
paper and not Etoys.
Pencil and scissors, or paper and scissors is how we do it.
Yes.
This is excellent, thank you. I love it.
You're welcome.
I
So-
did other presentations.
I hand over to Kathleen.
I think minutes, and I think we should take a break,
Okay.
because there's a presentation at 11.
I asked my question maybe. Yeah, I know, but I think that looks to me as a nice vehicle to introduce computer science, because you can actually deconstruct these steps you are going to do in an algorithm. Would you think that it just occurred to me, I don't have thought that through, but maybe you can to learn the basics of programming, would you think that these step by step, doing everything yourself is helpful?
That's my point, exactly. I think.
Not sure. I
The
mean,
kids who are
you
learning to
would
program.
you would need to know where you want to end up.
Yeah.
So reinventing these things in Etoys. I mean, you could make a project, or the teacher could make a project with the simple building blocks for your CS curriculum, and for that Etoys would be a good tool, in my opinion, because given these blocks, once the kids reach a certain level of fluency in Etoys, they can go in and see how it's done. And that's the power of Etoys.
I was talking about
Right.
university students.
Yeah, even the
Yeah,
university
yeah.
students.
Yeah.
Because most of the tools that even university students use, you cannot look into.
Yeah.
They're just much too complex, and maybe you don't even have the source code, or if you have the source code, you cannot get it, you cannot run it. It's much too hard.
It's magic, and if you can
It's
look
magic,
into it,
yeah.
you can really follow
Figure out to just tweak it, to do a little bit different, yeah.
Yeah. Yeah. So I was looking here in our examples, if there was an example for constructing your own language. It appears we didn't put it in, but you can do that not only for this animation kind of tiles, but for any like logic. There's a little logic game here. I hope you've seen that, where you construct logic gates just from using a custom animation, a costume animation. So that's, to me, this is similar, because you make these generic tiles here in Etoys, and then you can build any circuit. So it's the same idea, I would say. All right. So 5-minute break before the next talk. Thanks, everyone.
No,